Just think about yourself. Right now, while you sit perfectly still, you are hurtling through the universe at unimaginable speeds. Your planet is spinning. Your star is moving. Your galaxy is falling through space towards something we cannot even see. And the most terrifying part? This is only the beginning. At this moment, you probably feel completely still. Maybe you are sitting in a chair, lying in bed, or standing quietly in a room. Everything around you appears stable and unmoving. The walls seem fixed. The floor feels solid beneath you. Nothing appears to be in motion. But that sense of stillness is an illusion created by your brain. In reality, absolute rest does not exist anywhere in the universe. What you experience as standing still is simply your mind filtering out unimaginable motion, so you can function without becoming overwhelmed. Your body is currently moving through space in ways that are almost impossible to comprehend. To begin with, Earth is spinning on its axis nonstop. Near the equator, that rotation reaches speeds of roughly 1,000 miles per hour. Even now, while you feel perfectly calm and stationary, you are rotating with the planet at incredible velocity. But Earth is doing far more than spinning. Our planet is also racing around the Sun. To complete one orbit every year, Earth travels through space at around 67,000 miles per hour, roughly 19 miles every second. By the time you finish reading a single sentence, you have already moved hundreds of miles through the vacuum of space without noticing it. And that is only a tiny fraction of the motion happening around you. The Sun itself, carrying Earth and the entire solar system along with it, is orbiting the center of the Milky Way. Deep at the galaxy's core lies a supermassive black hole, and our solar system is circling it at astonishing speed. At this very moment, you are traveling through the galaxy at roughly 514,000 miles per hour. And the motion is not simple or straight. As the solar system orbits the galaxy, it also rises and falls through the galactic plane in a slow wave-like motion, almost like a ship drifting through enormous cosmic tides. But the movement does not stop there. The entire Milky Way galaxy itself is moving through space. Alongside the Andromeda Galaxy and many neighboring galaxies, we are being pulled toward a mysterious gravitational region astronomers call the Great Attractor. No one fully understands what exists there, yet its gravity is dragging entire galaxies across the universe. Our galaxy is plunging toward this invisible destination at nearly 1.3 million miles per hour. When all of these motions combine, Earth's rotation, Earth's orbit around the Sun, the Sun's orbit around the galaxy, and the galaxy's movement through the cosmos, the result is staggering. Even while you feel completely still, you are actually hurtling through space at extraordinary speed, following a massive spiraling path through the universe that will never occur in exactly the same way again. You have never occupied the exact same position in space twice. The location where you started reading this paragraph is already millions of miles behind you, permanently unreachable. You are riding on a tiny world swept through the cosmos like dust inside a giant storm. And from the moment you were born until this very second, you have never truly stopped moving. Alright, let's go with a famous saying, time and tide waits for none. What you think is actual time differs. The concept of time dilation. The space-time and Earth-time are two different things. Humans naturally think of time as something fixed and absolute. 1 second feels identical to every other second. Minutes pass uniformly. Hours move forward with mechanical precision, as though the universe itself were governed by a giant invisible clock. But this understanding is completely wrong. Albert Einstein revealed that time is not constant at all. It is not some universal rhythm shared equally by every object in existence. Instead, time is part of a larger structure called space-time, a flexible fabric where space and time are woven together. And that fabric can bend. Two things distort it more than anything else: gravity and velocity. This means the flow of time changes depending on where you are and how fast you are moving. The stronger the gravitational field around you, the slower time passes relative to someone farther away. And the faster you travel through space, the more slowly you move through time compared to people at rest. This sounds like science fiction, but it is a measurable fact of reality. Modern civilization actually depends on correcting these distortions every single day. Take the GPS system used by your phone for navigation. The satellites orbiting Earth travel at roughly 8,700 miles per hour and operate thousands of miles above the planet's surface. Because of their enormous speed, Einstein's theory of special relativity predicts that the atomic clocks on board those satellites should run slightly slower than clocks on Earth. But another effect occurs at the same time. Since the satellites are much farther from Earth's gravitational pull, they experience weaker gravity than we do on the ground. According to general relativity, weaker gravity causes time to move faster. The two effects fight against each other. Velocity slows the satellite clocks down, while reduced gravity speeds them up. In the end, the clocks aboard GPS satellites tick slightly faster than clocks on Earth by about 38 microseconds every day. That difference sounds tiny, but if engineers failed to correct for it, the entire GPS network would become dangerously inaccurate almost immediately. Navigation systems would drift by miles within a single day. Air traffic systems, military targeting, shipping routes, communications networks, and transportation infrastructure would begin collapsing into chaos. Your daily life already depends on relativistic time distortion being accounted for constantly. And these effects are happening to you right now. Because gravity becomes weaker with height, time moves slightly faster at the top of your body than at your feet. If you live high in a skyscraper, you are technically aging a tiny bit faster than someone standing at street level. The difference is microscopic, but it is real. Near extremely massive objects, these distortions become terrifyingly extreme. Close to a supermassive black hole, gravity becomes so intense that time nearly stops relative to the outside universe. A person spending only a few hours near the edge of such a black hole could return to Earth and discover that centuries or even thousands of years had passed. Everyone they once knew would already be gone. Time is not universal. It is not experienced equally by all observers. Every person, every planet, every star exists. Humanity takes enormous pride in its ability to observe the cosmos. We have constructed giant observatories across deserts and mountains. We have launched advanced telescopes beyond Earth's atmosphere into the darkness of space. We can detect ancient radiation left behind by the Big Bang itself. We can observe exploding stars, distant quasars, and galaxies billions of light years away. It feels as though we understand the universe because we can see so much of it. But that confidence hides a terrifying reality. Everything humanity has ever directly observed, every planet, every star, every nebula, every black hole, every atom inside your body, represents only a tiny fraction of existence. Roughly 95% of the universe is completely invisible to us. According to modern cosmology, ordinary matter, the matter that forms humans, worlds, stars, and galaxies, accounts for only about 5% of the total universe. The remaining majority exists in forms we still cannot fully explain. About 27% of the cosmos appears to be made of something called dark matter. Dark matter is not called dark because it is black or shadowy. It is called dark because it does not interact with light in any detectable way. It neither emits light nor reflects it. It cannot be seen with telescopes because it ignores the electromagnetic forces that allow normal matter to be visible. If dark matter passed directly through your body, you would never notice. You could not touch it, smell it, hear it, or see it. And yet scientists are convinced it exists because galaxies should not physically survive without it. When astronomers measure how fast galaxies rotate, the calculations make no sense. The visible stars and gas inside galaxies do not contain enough gravity to hold them together. The outer regions spin so quickly that the galaxies should tear themselves apart and scatter into empty space. But they do not. The stars are already dead. Yes, you are staring into a massive cosmic graveyard. Ancient dead stars glowing in night sky, cosmic graveyard, melancholic space atmosphere. On a clear night, when you stare into the sky, it feels like you are witnessing the universe exactly as it exists in this moment. But that feeling is an illusion. The sky you see is not the present. It is a collection of ancient signals arriving late from the distant past. In many ways, the night sky is a cemetery filled with the fading echoes of long-dead stars. This strange reality exists because of one unbreakable law of nature, the speed of light. Light moves at roughly 186,000 miles per second, an almost incomprehensible speed. In everyday human life, it feels instantaneous. You press a button and a room lights up immediately. But on the scale of the universe, even light is painfully slow. The cosmos is so enormous that light requires time to travel across it, sometimes years, centuries, or even millions of years. Because of this, every time you observe the universe, you are also looking backward through time. Telescopes are not just tools for seeing distant objects. They are machines that reveal history. When you look at the moon, you are seeing it as it existed about 1.3 seconds ago, because that is how long moonlight takes to arrive at Earth. When sunlight touches your skin, that light actually left the surface of the sun more than 8 minutes earlier. If the sun somehow disappeared instantly, humanity would remain unaware for over 8 minutes, continuing to orbit a dead center while its final light still streamed toward us. Once we look beyond our solar system, the delays become far more extreme. The nearest star system, Proxima Centauri, is over 4 light-years away. The image you see tonight is actually over 4 years old. Sirius, one of the brightest stars in Earth's sky, appears to us as it existed more than 8 years in the past. And those are only nearby stars. The galaxies captured by powerful observatories like the James Webb Space Telescope exist at distances so enormous that their light began traveling long before human civilization existed. In some cases, before humans existed at all. The photons entering your eyes tonight may have spent thousands, millions, or even billions of years crossing the freezing emptiness of space. They traveled through cosmic dust, past collapsing stars and black holes, surviving an unimaginable journey simply to end inside your retina. And this leads to a deeply unsettling truth. Many of the stars visible in the night sky are probably already dead. Some exhausted their fuel ages ago. Some collapsed inward under their own gravity. Others exploded violently in supernovas, leaving behind only neutron stars or black holes. But their light is still traveling. Their final glow continues racing across the universe like a ghost cruising to the sun. So when you look into the heavens, you are not truly seeing the universe as it is now. You are witnessing ancient history. The lingering from tiny sand particles, from the drop of water to the edge of universe. The never-ending universe. The theory 1920, universe is expanding, showing red shift. Since then, the expansion has become a core aspect of the astrophysical field of cosmology. Differently now, we are going the most mysterious thing in the universe. Edge of observable universe, galaxies disappearing into darkness, terrifying cosmic isolation. Humanity has always been obsessed with exploration. We crossed deadly oceans to discover new lands. We escaped Earth's gravity and set foot on the moon. Deep down, we assumed that with enough intelligence, advanced technology, and enough time, we could one day travel across the entire universe. But that assumption may be completely wrong. The universe is not an endless frontier waiting to be explored. In reality, enormous portions of the cosmos are permanently unreachable. Invisible boundaries surround us, and those boundaries are expanding faster than we could ever pursue them. This is the terrifying concept known as the cosmic horizon. Since the moment of the Big Bang, the universe has been expanding outward. But the situation is even stranger than it first appears. Due to a mysterious force called dark energy, this expansion is accelerating over time. Galaxies are not simply flying through empty space away from one another. Instead, space itself is stretching. The actual fabric of the universe is expanding between galaxies like an ever-growing cosmic web. And unlike objects moving through space, space itself is not restricted by the speed of light. While nothing inside the universe can travel faster than light, the expansion of space can exceed that limit without violating physics. Around us exists a vast, invisible boundary called the observable universe, extending roughly 46.5 billion light-years in every direction. Beyond that limit, distant galaxies are being carried away by the expansion of space faster than light can travel toward us. That creates a horrifying consequence. Now we are going the most mysterious thing in the universe. The black holes. The black body radiators. They are the most terrifying objects in the known universe. They are regions where gravity becomes so overwhelming that absolutely nothing, not even light itself, can escape their grip. Scientists understand the outer boundary known as the event horizon, the final border beyond which return becomes impossible. Cross that boundary, and the immense gravitational forces would stretch your body into an impossibly thin stream of particles in a brutal phenomenon known as spaghettification. But the event horizon is only the entrance. The true nightmare exists far deeper inside. At the center of every black hole lies something called a singularity. And a singularity is not merely a place where gravity becomes extreme. It is a location where our entire understanding of reality completely collapses. To grasp why the singularity is so disturbing, you need to understand the two greatest achievements of modern physics. The first is Einstein's theory of general relativity, which explains gravity and the behavior of space and time across stars, galaxies, and the cosmos itself. The second is quantum mechanics, the mathematical system that describes the bizarre behavior of atoms and subatomic particles with astonishing accuracy. Both theories work flawlessly in their own domains. They are among the most successful scientific models ever created. But inside a black hole, they become incompatible. The moment scientists attempt to describe the singularity using both theories together, the mathematics breaks apart completely. The equations contradict each other. The laws of physics stop making sense. Black holes form when massive stars collapse under their own gravity after running out of fuel. The star's enormous mass becomes compressed into an unimaginably tiny region. According to current calculations, all of that matter is crushed into a point with zero size and infinite density. And that is where the problem begins. In physics, infinity is usually a warning sign, not a real physical answer. It often means the equations themselves have failed. When researchers apply Einstein's equations to the center of a black hole, the calculations produce impossible results, mathematically similar to dividing by zero. The formulas stop giving meaningful answers. At the singularity, the normal rules of existence may completely vanish. Concepts like distance, direction, past, and future may lose all meaning. Some theoretical models suggest that space and time could exchange roles inside a black hole, meaning traveling toward the center becomes as unavoidable as moving forward through time itself. Other ideas are even stranger. Some physicists speculate that singularities could connect to white holes, act as tunnels to distant regions of the universe, or even open pathways into entirely separate universes. But these ideas remain purely theoretical. The disturbing reality is that no one truly knows what exists there. And worse, we may never know. The singularity is permanently hidden behind the event horizon, sealed away from observation. No information can escape to tell us what lies inside. Beyond that boundary may exist a realm where the laws governing reality no longer function. A place where space, time, and physics dissolve into something the human mind. Let's discuss what we are. We are stars' dust. Or we can say that you are a walking graveyard of dead stars. We often look up at the night sky and feel a profound sense of separation. The universe feels like a cold, hostile place, infinitely distant from the warm, chaotic reality of human life. We view space as a container, a vast, empty room in which Earth happens to exist. But this perspective is scientifically incorrect. You are not separated from the cosmos. You are intimately, biologically, and violently connected to it. When the universe was born 13.8 billion years ago in the Big Bang, it was incredibly simple. The explosion of creation only produced the lightest, most basic elements, mostly hydrogen, some helium, and a tiny trace of lithium. That was it. For millions of years, the universe was nothing but a swirling soup of hydrogen gas. But human beings are incredibly complex. We are made of heavy elements. You have carbon in your cells, forming the foundation of your DNA. You have calcium hardening your bones and teeth. You have nitrogen in your brain. You have iron pumping through your veins, binding with oxygen to keep you alive. None of these elements existed at the dawn of time. So where did they come from? They had to be forged. As the early hydrogen gas clumped together under gravity, the pressure and heat became so intense that nuclear fusion ignited and the first stars were born. Deep inside the cores of these massive ancient stars, the temperature reached millions of degrees. The crushing pressure acted as a cosmic forge, smashing hydrogen atoms together to create helium. Then it smashed helium to create carbon, then oxygen, then silicon. But a star can only fuse elements up to iron. Fusing iron requires more energy than it releases, causing the star's internal engine to fail. When these massive ancient stars ran out of fuel, gravity won. The star collapsed in on itself in a fraction of a second, rebounding in one of the most violent events in the cosmos, a supernova explosion. In the unimaginable heat of that explosion, the heaviest elements, gold, uranium, platinum, were forged in an instant. The star then blasted all of these newly created elements out into the freezing void of space. For billions of years, these clouds of star stuff drifted through the dark. Eventually, they coalesced. They formed a new star we call the Sun. They formed a rocky planet we call Earth. And they formed the biological machinery that eventually evolved into you. Every single atom of carbon in your body, every ounce of iron in your blood was synthesized in the nuclear furnace of a star that exploded and died billions of years ago. You are not just living in the universe. You are the universe. You are stardust that has clumped together, grown a brain, and gained the ability to look back up at the sky and wonder where it came from. It is a beautiful, deeply profound thought, but it carries a heavy weight. You are a walking graveyard of dead stars, briefly animated by energy, trying to find meaning in the void. At this very moment, the cosmos is quietly drifting. The death of universe. Humanity has always feared the ending of the universe right now. We imagine catastrophic asteroids, global wars, collapsing civilizations, and extinction-level disasters. We worry about whether our species will survive and what traces of us will remain after we are gone. But the true ending is far larger than Earth, far larger than humanity. The greatest tragedy imaginable is not the death of our planet. It is the eventual death of the cosmos itself. And the terrifying part is that this ending is not some sudden explosion waiting in the distant future. It is a slow and unstoppable process that began billions of years ago and continues even now. This fate is driven by one unavoidable rule of physics, the second law of thermodynamics. Entropy always increases. In every closed system, order slowly breaks apart into disorder. Energy spreads out. Heat moves from warmer regions to colder ones until balance is reached everywhere. And the universe itself may be the ultimate closed system. At this moment, we exist within what scientists call the stelliferous era, the age of stars. It is the brilliant golden age of the universe. Galaxies shine brightly. Stars are actively burning. Worlds form. Life exists because immense amounts of usable energy still flow through the cosmos. But this era will not last forever. The fuel that powers the stars is limited. As dark energy continues stretching the fabric of space faster and faster, galaxies will drift farther apart until they become isolated islands in an endless darkness. Over unimaginable spans of time, the stars themselves will begin to disappear. Massive stars will explode in violent supernovas. Stars like our sun will expand into red giants before cooling into fading white dwarfs. Even the tiny red dwarf stars, capable of surviving for trillions of years, will eventually exhaust their fuel and go dark forever. Then begins the degenerate era. The sky will become completely black. No sunlight, no glowing galaxies, no warmth. Only the dead remnants of ancient stars will remain. Black dwarfs, neutron stars, and black holes drifting silently through the frozen void. But entropy never stops. Over incomprehensible stretches of time, planets will lose their orbits. Some will be swallowed by black holes. Others will wander endlessly through empty space. Even matter itself may not survive forever. The particles that form atoms could eventually decay, dissolving reality into an incredibly thin sea of radiation and subatomic debris. After that comes the black hole era. By then, the only surviving structures in existence may be supermassive black holes. Yet even black holes are not eternal. Through a phenomenon predicted by Stephen Hawking known as Hawking radiation, black holes slowly lose energy over unimaginable lengths of time. Trillions upon trillions of years will pass as they gradually evaporate, shrinking until the final black holes vanish in faint flashes of energy. And when the last black hole disappears, the universe enters its final stage. The dark era, maximum entropy, an endless, freezing expanse stretching beyond imagination. No stars, no planets, no light, no galaxies, no life, possibly not even atoms. Only darkness approaching absolute zero. This is the predicted heat death of the universe, a state where all usable energy has been exhausted and nothing meaningful can ever happen again. No civilization can stop it. No technology can reverse it. No intelligence, no matter how advanced, can escape the direction of entropy.